Okay, in this lecture we're going to talk about inspection analysis. And what we mean by inspection analysis is that we're going to recognize that the inputs and outputs on transistors are often in very similar places. They form amplifiers that we well know, like the common source, common emitter, common base, common gate amplifiers, for instance, and that the gains of these amplifiers, when their inputs and outputs are in similar places, are usually pretty similar themselves. So in starting inspection analysis, the first thing that we need to do is find the operating point. We're going to find all DC node voltages and currents, and these are going to be used to find the small signal parameters that we're going to use to calculate the gain. But note, we're not going to actually use the small signal model. We're just going to use the parameters. We know that the parameters that we're going to be interested in are going to be things like GM, R pi, and R out, depending upon whether we're looking at a MOS amplifier or a BJT, we might not have the R pi. Next, we're going to convert the circuit for small signal analysis. To do so, first we short the DC voltage sources, we open the DC current sources, and we short the big capacitors. Now you can redraw the schematic and do this, or as you get more practice, you'll notice that you can just do this mentally. Finally, we're going to analyze the network based upon the topology of the amplifiers that we're looking at. And what do we mean by topology? We mean common emitter, common source, the topologies that we've learned about in the prior lectures, for instance. Oftentimes, we're just going to abbreviate these as CE, for instance, for common emitter, CS for common source, CG for common gate, so on and so forth. Now, in general, the voltage gain for the voltage amplifier gain is given by the following. AV is equal to minus big GM times big RT. GM is the total transconductance, including the external components that are connected to the circuit. Big RT is the resistance that transconductance drives. So for a voltage amplifier, the operation is generally that the transistor with its external components converts the voltage of the input to a current. That current is driven into a resistor, and the resistor converts the voltage back, or the current back to a voltage. We define big GM as the change in current at the output node divided by the change in voltage at the input node when the output node is short-circuited. And big RT is defined as the change in voltage at the output node divided by the change in current at the output node when the input node is short-circuited. All right, so we'll stop there, and then we'll look at an example on the next lecture video.